So we have seen two polythenes and one polypropylene as monomers. And now we'll be seeing the fourth example of polymer. So we are basically making a table of all of them. So we have CH2 with a double bond and CH connected to a pH group, and N units of this we are taking, and this monomer is called styrene, which on polymerization will give us CH2 single bond CH pH group attached to it, and we have got N units of this, and this polymer is known as polystyrene, that is many styrene. Okay, so this is an example of addition polymer again. The fifth one that we'll be dealing with has the monomer, which is CH2 double bond CH with a Cl, and this monomer is known as N units of this monomer is called vinyl chloride. So vinyl chloride on polymerization gives us the same structure CH2, the single bond CH and a Cl, and N units of this is being developed, and this is called polyvinyl chloride, referred to commonly as PVC, polyvinyl chloride. Okay, so now the next that we'll be dealing with the sixth one. The sixth one is CH2 double bond CH with the CN group attached to it. N units of this we are taking. This is known as acrylonitrile. Okay, which on polymerization will give us CH2 with a single bond along with CH, and we have CN attached to it. So N units we are getting, and this is known as polyacrylonitrile. Okay, now this polyacrylonitrile can be called PAN. The seventh one that we'll be seeing is C double bond C with 4 fluorine completing the valency of carbons. So we have this, and this is known as N units of this. So this is called tetrafluoro, that means 4 fluoro, and we have ethene group. Now this on polymerization gives us, so we can represent this as CF2, a single bond, the F are being represented as this, and N units of this, and we call this poly tetrafluoroethene, and this is commonly known as Teflon, which you might have heard. Also, the P refers to poly, T refers to tetrafluoroethene, also known as PTFE. This polytetrafluoroethene that is just drawn is used for non-stick surface coated utensils, as you might have remembered. So Teflon is manufactured by heating tetrafluoroethene with a free radical or persulfate catalyst at high pressure, and this Teflon is chemically inert and resistant to attack by corrosive reagent. So it is used for making oil seals and gaskets, and also used for non-stick surface coated utensils. Okay, so this is Teflon. Now, the next one, the eighth one that we'll be dealing with. So the eighth one is the monomer looks like this, C double bond. We have another C, and this the first one has Cl, then it has the fluorine group, then it has 2 fluorine more. So we have this particular monomer, and this monomer is called, so it is known as chloro trifluoro As you can see, there are three fluorines, so trifluoro. Then we have ethene, and this on polymerization. So n units of this will lead to the formation of the polymer, which is ClF. Then we have C and two more Fs, F and F. So we have got n units of this being developed, and this is known as, of course, the poly word will be added, will be an extra addition to the name. So polychloro trifluoroethene. Okay, this is the eighth one. Coming on to the ninth one. So the ninth one is CH2 double bond C with a CH3 group on top and COOMe group at the bottom, and this is known as methyl. Then we have metha, so methyl, metha, and then we have acrylate. So n units of this on polymerization will lead to the formation of the polymer, which is CH2 single bond C, CH3 at the top, then we have COOMe at the bottom, and n units of this, which will be referred to as polymethyl, polymethyl metha acrylate. Now this is known as polymethyl metha acrylate, PMMA. Okay, so these are 9 polymers that we have seen. So the next one, the 10th one, is natural rubber. Natural rubber we have dealt with already. Natural rubber was cis polyisoprene. So to draw the natural polymer, we have the monomer, that is isoprene. So it is CH2 with a double bond. Then we have CH3 attached. Then we again have a CH double bond and a CH2. N units of this, and we will obtain two kinds of isomers. One being the cis form. So the cis form looks something like this: CH2, C double bond C. Then we have CH3 here. Then we have H over here. Then we have CH2 over here. And we have N units of this. And this is the cis form, referred to as natural rubber. Okay, here only we will see the 11th one also. So geometrical isomers are being developed. So the cis and the trans form both are being developed with the help of these isoprene that we had as a monomer. So isoprene, polyisoprene being formed. One is the cis form, that is natural rubber. The other is the trans form, which looks something like this again. So we have got CH2 group over here, and we've got C double bond C. Now the positioning is a little different. So we have got CH3 over here, then we have CH2, and we have N units of this. Now this is known as the transform, and the transform of polyisoprene is known as we previously discussed, this was called gutta-percha. Okay, so we are done with 11. Now the 12th one, is, we've already done this also, it is polychloroprene. So here the monomer is CH2 double bond CCl with CH, a double bond and a CH2. And this monomer is called chloroprene. And chloroprene on polymerization, n units of it, will lead to the formation of the polymer, which looks something like this. So we have got CH2, CCl, then we have got a double bond CH, CH2. So this is known as polychloropene. And as you know, 1,4 type of addition was taking place over here, and polychloropene is also known as diprene. So now we have dealt with 12 of the addition polymers, and all of them were homopolymers because they were formed only from similar species. So they all are homopolymers because only one, that is homo species, were being used.